For g of x, we need to find two zeros using the calculator, because if we have the degree being 4, in order to reduce that down to a quadratic where the degree will be 2, I'll need to find two zeros, use synthetic division, and go from there. So what we're going to do is we're going to plug in this function into the calculator. So you get 2x to the 4th plus x cubed plus 5x squared plus 4x minus 12. So again, two ways to do this. To find zeros that are going to be whole numbers, you can press second table or second graph, which will bring you to table. And you can look for places where your y is a 0. We found one right here. So when x is 1, y is 0. So I'm going to write that one down. So I know one of my zeros is where x equals 1. I can look around a little bit more. Numbers are starting to get really big, so what I can do is I can go to the graph. And I can see I have two zeros there. So I'll press second trace, go to 0. It asks me for the left bound, so I'm going to scroll till I see my cursor. My cursor is blinking here. Again, a good way to check to make sure that you are doing this correctly is if you start with a positive y as your left bound, then when you go to the right, your y should be negative. Or if you started negative, it should change to positive. Because again, we're looking for when y is 0, so it needs to be between when it's positive and negative. So my left bound, positive, right bound, negative. I don't need to guess. And I've got 1.5. Oh, sorry, negative 1.5. I'll use those two zeros to help me find the rest of my solutions. So now what I'm going to do is I'm going to use synthetic division again. Remember that your synthetic division, you'll use your zeros. You can use either one to start. I'll use 1 just because it was first. Then I'm going to write out the coefficients, or the numbers that are outside or beside my variables, making sure that if I'm going in descending order, that if any of my x degree terms are missing, like if x cubed wasn't here, you would need to put a placeholder of a 0. This one goes 4, 3, 2, 1, 0. So we don't actually need any placeholders for this one. My coefficients are 2, 1, 5, 4, negative 12. I'll perform synthetic division by bringing down that first term. Then I'm going to multiply 2 times 1. So 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. 5 plus 3 is 8. 1 times 8 is 8. 4 plus 8 is 12. And 1 times 12 is 12. Negative 12 plus 12 is 0. You're always looking to get that remainder to be 0. If your remainder is not 0, then it either wasn't a 0 or you did some of your math incorrectly along the way. Now, what these numbers represent, this is your constant, x squared, and x cubed. I'm trying to get it down to a quadratic because I know how to solve quadratics with either factoring, complete the square, quadratic formula. So this is not quite a quadratic yet. I'm going to need to do another round of synthetic division with negative 1.5. So I'm going to bring my 2 down. And 2 times negative 1.5 is negative 3. 3 plus negative 3 is 0. Negative 1.5 times 0 is 0. 8 plus 0 is 8. 8 times negative 1.5 is negative 12. And when you add these together, you get 0, which is what you're looking for. Remember that last number is always going to represent your remainder. You want that remainder to be 0. This is my constant. This is x, and this is x squared. So now I have 2x squared plus 8 as a factor, x minus 1 as a factor, and x plus 1.5. I need to simplify this. But what you can do is you could typically use the quadratic formula for everything in order to find those zeros, but I am just going to take this factor and set it equal to 0 so that I get 2x plus 8 equals 0. I will subtract 8 from both sides of the equation and I get 2x equals negative 8. Oh, I'm sorry, squared. I forgot my squared. Now I'll divide both sides of my equation by 2 and x squared equals negative 4. If I take the square root of both sides, the square root of negative 4 is plus or minus 2i. So that gives me two solutions, a positive 2i and a negative 2i. I have two solutions here, 1 and negative 1.5. My degree was 4, so everything is now accounted for. So plus or minus 2i. If you are writing everything out in factored form, you could say x minus 1, x plus 1.5, x minus 2i, x plus 2i. And that would be your factored form for the function, oh I'm sorry, it's a g, not an f, g of x.